In this video, we'll be going over the basics of the normal and binomial distribution. The basic empirical rule that applies to all normal distributions is that 68% of the data fall within one standard deviation of the mean, 95% fall within two standard deviations above or below the mean, and 99.7% of data fall within three standard deviations of the mean. In the previous video, we touched on z-scores and how to calculate a z-score and what it tells us. Z-score will tell us how many standard deviations away from the mean an observation is. And again, the z-score formula is our observation value minus the population mean divided by the population standard deviation. This is the z-table. And what the z-table does is it gives us the area under the curve for a given z-score. This area represents the probability that z-values will fall within a region of the standard normal distribution. So for example, if we look at our z-table here on this slide, we want to find the area under the curve for a z-score of negative 2.57. So we have a score that falls 2.57 standard deviations below our mean. And if we look at our z-table and in the z column, look down to where it says negative 2.5 and over to the column where it says 0.7. And we'll find that our z-value is 0.0051. If we move the decimal over two places and convert this to a percent, this value indicates that about 0.5% of our scores are likely to fall below our z-score of negative 2.57. The binomial distribution is another distribution in addition to the normal one that we'll see and kind of use a lot in statistical analyses. So we have a couple parameters for this kind of distribution, n being our number of trials and p being our probability of success. We use binomial distributions with dummy variables, where success means that you either have the trait or the thing, and failure means that you don't have the trait or whatever thing we're looking at. Binomial distributions follow three underlying assumptions. Number one being that the number of trials, n, is fixed. Two being that the variables are binomial. There are only two possible outcomes: success, having it, or failure, not having. The variable is IID, independent and identically distributed. What does IID mean? Being independent means that the outcome of any of the n number of trials has no effect on the outcome of any of the other trials. Identically distributed just means that the underlying probabilities are the same for each of these n trials. And this is sometimes known as trials with replacement. So a dummy variable, or a Bernoulli variable, can take on two values, 0 or 1. P is our proportion of success, 1 minus P is the proportion of failures, N is our number of trials, and C is the number of successes that we would like to get a probability for. So the equation for a binomial distribution is right here on this slide, where N is our number of trials, P is the probability of success, and C is our number of successes that we would like to obtain a probability for. Since I'm obviously not going to make anybody solve that big equation by hand, we're going to use Excel for this in the next corresponding video. But before we start, I'll give an example. What is the probability that at least 7 students have taken statistics before? So, if we want to find the probability that at least 7 of our students in class have taken statistics before, we plug a 7 into our equation, and we can find that the probability is about 11% that 7 students at least have taken stats before. As our number goes up, the probability that that number of students in the class has taken statistics before, we can see, decreases. And we'll illustrate more of this in the next corresponding video in the Excel and R practices.